fine. Start. Okay, so let's begin. I would like to do from problem set 2. I had left number 1. Okay, so number 1, the statement was this. Let me very quickly write down the statement. Let summation an x to the power n greater or equals to 0 be a power series with radius of convergence equals to 1. Suppose this series can you mute yourself, converges to A, then show that limit r tends to 1 minus with the left hand limit. So an r to the power n, this is nothing but A. So this is actually Abel's theorem. Okay, this is Abel's theorem in complex analysis. We have a similar version in real analysis also. So to prove this one, I will share a PDF. From there you can see the proof of this one. It is straightforward, so I will not discuss the proof of this. Is basically a theorem. Okay, I'll share you a PDF where you can find the proof. The proof part is up to you. Okay, and on the next thing what I have to show that, prove that using the above result, prove that log 2 is actually this 1 minus half plus 1 by 3 minus 1 by 4 and so on. So I'll be doing this part. Okay, the first part is Abel's theorem. I'll attach a PDF. You can just see the proof from there. And to do this one, so you see how to approach for this one. You have to take a power series. Okay, so I'll take this power series. So set g of x as, I'll use capital X. So this as summation n greater or equals to 1 minus 1 to the power n minus 1 by n x to the power n. I am taking this power series. What is the radius of convergence of this power series? Can you check and tell me? What is the radius of convergence of this power series?
1.
1. You can use the lim supremum of modulus an whole to the power 1 by n. That will give you 1. And this was also discussed, I guess, in the problem sheet 1. So its radius of convergence is 1. So you see, if you see this, I have got a power series and I have got the radius of convergence to be 1. Now, what I also want, I need the coefficient series converges. So suppose, not suppose, I have to prove actually that this converges. The series this series, the series of the coefficients, so minus 1 to the power n minus 1 by n. So this is a real series, the series of real numbers. Will this series converge?
Yes, sir.
Yes, sir. By Leibniz.
By Leibniz
Right.
test.
1 by n is monotonically decreasing, and so the alternating series will converge, and that 1 by n tends to 0, right? So the series converges, okay, and this will converge. You can just write converges by some, okay, I'll not write that anyways. So this series converges, and this converges to g of 1, because this series is nothing but after obtaining by putting x equals to 1 in this here, right? 1 in the above thing. So the series converges. The series g of 1 converges. Now, one thing you have to take here for assumption. Then g of x, this is nothing but the power series of log 1 plus x. This you have to assume here. You can actually prove also. So gx is log of 1 plus x. Okay. This is the power series of this. So if I use the Leibniz, if I use the above result, so therefore g of, okay, so if I use the above result, limit r tends to 1 minus this power series n greater or equals to 1. I have this power series. I have to take r to the power n. This will go to g of 1. So that is limit r tends to 1 minus, this is nothing but g of x is nothing but g of 1, or limit r tends to 1 minus g of x is nothing but log of 1 plus x, or r, because I have taken a r, log of 1 plus r, that is g of 1, or because log is a continuous function, you can take that limit inside, so that will become log 2, and g of 1 is nothing but this series, so which is summation n greater or equals to 1 minus 1, and this is nothing but 1 minus half plus 1 by 3 minus 1 by 4 and so on. So hence we are done, right? So I'll provide a proof for Abel's theorem. Okay, I'll share a PDF with you all. You can just have a look. This is clearly a theorem, and this was the application. Just a minute.
Can we prove it like r tends to minus 1 as replaced by 1 minus h, then h tends to 0, और 1 minus h को बाइनोमियल से एक्सपांड कर दो, then h tends to 0, then नॉर्मल सीरीज बन जाएगा.
नो बट दैट इज जो तुम बोल रहे हो, जो लेफ्ट हैंड लिमिट को तुम उस हिसाब से कंप्यूट करोगे, दैट इज ओनली ट्रू फॉर रियल लाइन, राइट? बट वी आर इन द कॉम्प्लेक्स प्लेन नाउ. तुम आर नेगेटिव, दिस आर इज अ रियल नंबर, दैट इज माय क्वेश्चन. ये जो आर है वो रियल नंबर होगा, उसका गारंटीड है?
नो सर.
So I guess you have to just check that कि R real number होगा या नहीं होगा, that you have to check that, okay? But I don't think so R will be a real number. अगर ये real जैसा होता है तो it's fine, जो तुमने बोला वो correct है, okay? So I'm not going in much detail to this one. Okay, next we'll go to problem set 3. I'll quickly discuss without wasting your time. So what was the first question? Just a minute. The first question was, let U be a subset of C such that Z in U, we have minus Z in U, okay? Then a map, sorry, you know the definition of even function. So, okay, I'll not write that down, it's easy. So prove that an even entire function, has only even degree terms, right, terms in its power series expression, expansion around 0. So it's easy. I'll do for the even one, odd one will be up to you. It's very simple. Both are exactly same. So how to prove this? Because
as z and minus of z is sum.
Right. So since I have few conditions, since f is even, So by definition, what can I say? F of minus z is same as f of z. Okay. So from here, I'll talk about the derivatives, because why will I talk about the derivatives? Because in the power series expansions, the coefficients are basically given by the derivatives. Okay, so I have to check what can I say about the derivative. So let's talk about the first order derivative. So what is f prime of minus z? Acha, let me do it this way. So let's find out the derivative of the function. So what can I say about the derivative of the function? So this is by definition ddz of fz, and fz can actually be replaced by f minus z. Yes? Any problem? Okay. So what I am doing, I'm calculating the first derivative of the function. What is the derivative of this quantity? It is f prime at minus z, and the further derivative of minus z is minus 1. So that is, this is nothing but minus f prime. Do you agree?
Yes, sir.
Right. So what can you say from here? That what can I say about the derivative? Therefore, f prime is an
Odd function.
odd function. That's correct, because f of minus z, okay, I should write one more line. This implies f prime of minus z. I will shift minus to the left hand side. This is minus f prime z. So therefore, what can I say? Derivative of an even function is odd. So since f is even, therefore f prime is odd, f double prime is
Even.
again you have to prove that. Yeah, so if I take the derivative, so again you have to prove a result, so that is up to you. So prove that again in the similar manner. You can prove that derivative of an odd function is derivative of an odd function is even. That you can prove it. So this implies f double prime is even, so f triple prime is odd, and so on, right? So by induction, what can I say? That f of odd powers of the function, that sorry, not powers, the derivative, the odd derivatives of the function, these are always odd. Zero, one, two. Do you agree with this line which I have written?
Yes, sir.
Now one thing to note, if g is an odd function, then g of 0 is 0. The proof is extremely simple. I can show you the proof. So g of y, this I'll explain. G of minus z is same as minus g of z. Put g equals to 0, put z equals to 0. So that implies g of 0 is same as minus g of 0. That implies 2 times g of 0 is 0, and g of 0 is 0 because you are in an integral domain. So for an odd function, you have g of 0 is 0, but this is only true for an odd function, not for an even function. Keep that in mind. So whenever you have an odd function, the value of the function at 0 will be 0. So from this line, so therefore f of 2k plus 1 at 0 will be 0 for all k 0, 1, 2. So since f is entire, it has a power series expansion of the form fz is nothing but summation n equals to 1 up to infinity, or I should take from 0 cn z to the power n. Okay, what will be cn? Can I write it directly? What is cn? The derivative, right? Okay. Can you tell me at 0 divided by
n factorial.
Right. So this will only remain with, so if I call this line as star, so do you see all the odd terms will vanish. So using star, what can I say? This even one will only remain, n is even and it is running up to infinity, so only this will remain, because using star, if I use star, जितना भी odd derivative होगा वो 0 पे vanish करेगा, so this making cn going to 0 whenever n is odd. So do you have a problem in this proof? You can ask me. If you have a problem, you can ask me. You can write in a more better way. Let me see. If you have a problem, you can ask me with the proof. Should I move to the next question then?
Yes, sir.
So, yeah, you can go do for the odd. When f is odd, you can start in a similar manner. It will be none. So number 2. What is the question? Suppose that let f be entire. Let f be entire such that you have a condition given that modulus of fz is bounded above by this thing a plus b, like this, for all z in C, so that f is a linear polynomial. Okay, so that f is a linear polynomial. So what I can do is, so because f is entire, it will have a power series expansion. I'll use that. So my point is that, you see, we have since f is entire, it has a power series expansion about 0, like this. So fz can be written as summation, okay, let me write k greater than or equal to 0 ck z to the power k, right? And this should hold for every z in C. So when I want to prove that f is a linear polynomial, my aim is that to show that C2, C3, C4, this and so on will all be 0. If I can prove this, then we are done. Okay, I want to prove that this is a linear polynomial. So my aim is that I want to prove that C2, C3, the coefficient C2, C3, C4, dot, they are all 0. Okay. So where? What can I say about CK? Where CK is what? Just now you had told me that this is the right FK 0. Okay, write it properly. Just a minute. So what is CK? Where CKs are the derivative of the function, the k derivative of function divided by k factorial. Okay. So do you remember the Cauchy's integral formula? What was the formula for the general version? Integration some function fz by z minus z0 whole to the power n plus 1 dz about a circle, say mod z equals to r, provided just a minute, provided this z naught is inside this circle. What is the value of this integral?
Fn at z
If k at z naught, fn at z naught
into 2
divided
pi.
by n factorial.
No, but 2 pi I should also be there because
Yes.
here I have not written 2 pi I.
Yes,
So
yes.
yes, 2 pi I divided by n factorial times the derivative of the function at z naught, right? I have written the formula correctly, right?
Yes.
Provided this, I should not, the circle should be like this, no? So sorry, this is z. Okay, I can write like this, right? And this will guarantee that z naught is inside this circle. Oh, no. Right. That will guarantee that the z naught is inside that circle of radius r. So let's turn this into an integration. So what is the value of fn z naught by n factorial using this formula? It will be 1 by 2 pi I integration of fz by, so instead of taking any arbitrary point, let me take z naught as 0 only. Okay, so this will become z to the power k plus 1 dz, and here modulus of z is r, where r is any circle of where r is any number more than 0, and that will definitely imply that the origin is inside this circle. Do you agree with me what I've written here?
Yes.
Right. So this will hold. So where for all k running from 0, 1, 2, I have this. So let us use the thing. So therefore, what is modulus of ck? Modulus of ck is modulus of this integration part, right? So modulus of this integration is, so modulus of 1 by 2 pi is 1 by 2 pi, and modulus of mod z equals to r fz by z to the power k plus 1 dz. So this modulus is bounded by, you can use the ML inequality. So what is M here? What is the bound of this function? What is the bound of this function over this circle? Can you tell me?
A plus b mod z to the
Right.
power 3 by 2.
That's right. I want to find the bound of this function over this circle, right? On this circle. So according to the thing, first of all, this is mod of fz by mod of z to the power k plus 1, and which is same as writing this, and this is nothing but r, because on this circle you see this mod z is r, so this is r to the power k plus 1, and this, and the above part is bounded by mod of fz is bounded by this. Okay, so a plus b. So instead of taking whole of z, I want to consider this as the over this circle. You have to take the bound on that circle. So maximum value that mod z can take is r and 3 by 2. So am I clear what I have written here? Why this is true?
Yes, so maximum value boundary पर ही
Right. So what is the maximum value here? So m is this, which is a plus b r to the power 3 by 2 and divided by r to the power k plus 1. This is the m, and what is the length of the curve? ml. What is the length here?
2 pi r.
2 pi r. That is a circle, you know, I have taken the complete circle. So its length will be 2 pi r. So this 2 pi and 2 pi will get cancelled. I'll remain with a plus b r to the power 3 by 2 by r to the power k. So my point is that when will this number go to 0? When this k is more than 3 by 2, right?
Yes, sir.
When the denominator is more, right? So k is more than 3 by 2, but k is an integer. So what I have, for k greater or equals to 2, modulus of ck is basically lesser or equals to a plus or a by r to the power k plus b by r to the power k minus 3 by 2. And because k is more than 2 or greater or equals to 2, so this will go to 0 as I choose r large, right? So therefore modulus of some number is less or equal to 0 as, so what will that mean? That will simply mean that the modulus is equal to 0, right?
Yes, sir.
And implying that modulus is 0 means the number is 0. So ck is 0 for all k which is more than 2, for all k which is more than 2. So therefore what I have, fz is nothing but c0 plus c1z, and of c2z square, c3z cube all vanishes because of this result. So proving that f is a linear polynomial. Any confusion, any doubts, you can ask.
So हम इसको डायरेक्टली नहीं कह सकते हैं, मतलब एक्सटेंडेड लियोलिथ थ्योरम सर ने प्रूव करा दी क्लास में, तो हम उससे डायरेक्ट नहीं कह सकते कि एट मोस्ट एटलीस्ट
You are right, but extended Liouville theorem में तुमने यहाँ पे एक इंटीजर अज्यूम किया था, जस्ट चेक करो.
एटलीस्ट का रहता है ना कि इतना तो होगा.
But if जब तुमने कंसिडर किया था एक्सटेंडेड Liouville theorem, आई होप यू हैव टेकन हियर इंटीजर के लिए तुमने प्रूफ किया, तुमने बेसिकली फ्रैक्शनल पावर के लिए नहीं प्रूफ किया. हाँ, द प्रूफ इज सिमिलर, जो मैंने प्रूफ किया है उसी हिसाब से प्रूफ किया होगा एक्सटेंडेड Liouville
यस
theorem
सर,
का.
यही.
हाँ, बट माय पॉइंट इज दैट वहां पे तुम लोगों ने यहाँ पे जो बाउंड लिया था वो एक इंटीजर लिया था, लाइक mod z टू द पावर n, एंड देन तुमने बोला था जो पॉलिनोमियल आएगा वो एटलीस्ट एट मोस्ट आई गेस एक डिग्री n पॉलिनोमियल होगा, राइट?
Degree.
यस सर.
Yes, sir.
Right. So this was number 2. Let me go to number 3. So number 3 be similar to this, that f be entire. So f is entire. So अगर f entire है, can I say that the derivative is also entire? So this I am writing.
Yes.
And f prime z is bounded by this for all z in C. So just take this line into consideration. And can you use the extended Liouville theorem?
Yes, sir.
So from the extended Liouville theorem, what can you say? So therefore, by
F prime Z has linear power.
right, extended Liouville's theorem. So when a function is entire and it is bounded by, so when this is bounded like this, right, a plus b modulus of z to the power n, then gz will be a polynomial of degree at most n. So what can I say from here by the extended Liouville theorem? F prime z is a linear polynomial. Right?
Yes, sir.
Okay, or of, I should not say linear exactly, of degree at most 1 I can say. Okay, anyways, just change it. Okay, is a, it can be constant also, so is a polynomial of degree at most 1. Okay, so now you can just write one more line. Say f prime z is this function az plus b. If a is 0, it will become a constant function, and if a is non-zero, it will become linear. So that is what we mean by degree at most 1. Okay, now what we know, f prime of z, will again use this condition, lesser equals to this for all z. Now whenever you see entire function, you are supposed to use the power series expansion in most of the cases, और power series जब भी आएगा, you have to consider derivatives at 0, जो हम लोग कब से कर रहे थे. You see, look at the coefficient, यहाँ पे coefficient देखो. So again we want to find out the derivative of the function at 0. That will help us in the power series. So from here if I put z equals to 0, because ये सारा z के लिए true है, so modulus of 0 is nothing but 0. So that implies this complex number is lesser or equals to 0. That makes no sense, which means this complex number का modulus equal to 0 है, मतलब this complex number is indeed 0, right? Whenever mod z is lesser or equals to 0, that will clearly imply that z is 0. That is the only possibility. Very obvious, right? So I have this quantity that f prime 0 is 0. So since f is entire, now I'll use the power series expansion. Since f is entire, so from here what can I say? F double derivative is a, and f triple derivative is all, and after that everything is 0. So f k z is 0 for all k starting from 3, right? Do you agree?
Yes.
So this will also mean that this is true for every z, so it is indeed true for 0. So since f is entire, and taking this star into country, and from star f can be written as, f has a power series expansion of the form, so f0 plus f prime 0 by 1 factorial z plus f double prime 0 by 2 factorial z square, and after that what we'll have, f triple derivative is 0 by 3 factorial z cube, but using star what can I say, they all will be 0. Okay, so पावर सीरीज में सिर्फ इतना ही टर्म्स बचेगा, इसमें से हम लोग और भी चीज को हटाएंगे. सो fz f0 let it be f prime 0 from here. If I call this as double star, so this is 0, I'll simply remain with this z square using double star. So what I have got till now, so call this as a b f of 0, and call this as b. Then fz is nothing but a plus b z square. The question, we are almost done except one part is remaining. तो पहला पार्ट क्या बोला था, show that fz is a plus b z square. So we are done. but हमको प्रूफ करना है, now हमको प्रूफ करना है to show modulus of b is lesser equals to half. So I want to prove that this quantity has modulus equal to lesser equals to half. Okay, any approach? How can I show that? again I'll use this concept which I have used here. The same ML, I should write here by ML inequality. So this is by ML inequality. So देखो मेरे को क्या दिखाना है that B is this I know, इसका मॉडुलस मतलब इसका मॉडुलस, and this is nothing but modulus of f prime 0 by 2. मतलब दिखाना है that this ऊपर का क्वांटिटी जो है वो 1 से बाउंडेड है. Okay, it has a upper bound 1. So ये I'll prove it now. So again let's use, we know integration fz by z minus, I'll not take here z minus z naught, I'll simply take z to the power n plus 1 dz, taking the circle of radius 1 for the time being. This is nothing but 2 pi I f n at 0 by n factorial, right? So put here 2. Why I'm putting here 2? Because I need the double derivative. So for n equals to 2, integration mod z equals to 1 fz by z square, sorry, this will be z cube, right? dz is 2 pi. I'm making some mistake.
So why we are taking mod z equals to 1?
See, I can take any number because here what is z naught here? I am taking z naught as 0. So if I take any circle around the origin of any radius, you can also take half, that doesn't matter. Okay. So
Okay, sir.
instead I'll just do a different thing. Just a minute. Delete. Okay, just see what I'm writing is right or wrong. We know 2 pi I f double prime 0 is f prime at w by w square dw. Is this right or wrong? Let's check this. What I have written is right or wrong. So let me show a calculation here. So I want to find this integration.
Hello, sir.
Right. Hello.
Sir, can we use our given condition for proving mod b is less than 1 by 2?
Which condition?
F of dash z mod is less than mod z.
Yes. How will you use that? Please tell me.
If we put fz equal to a plus b z square, then we can find out.
Okay. You are saying that from here, what you are saying that you'll find f prime z is nothing but 2bz, right?
Yes, sir.
And you are asking me to put there. Okay, so that means 2 modulus b modulus, acha, he's right, yeah, correct, that's good. Okay, so I was using more brain, maybe I did not consider this. That's a very good observation. Right. So for that, so fz is nothing but a plus b z square. That implies f prime z is 2bz. So from modulus of fz is lesser equals to modulus of z for all z in C. So this implies modulus of 2bz is lesser or equal
The
to
modulus of f prime z.
Right. Thank you. For all z in C, and if this holds for every z, so this is 2 times modulus of b times modulus of z lesser or equals to modulus of z for all z in C. So if it holds for every z, you can choose any particular non-zero z. So it will give you modulus of b is lesser or equals to half. Okay, thank you. So this was a easy way to attack. Okay. What next? Number 4. So I tried number 4 somewhere, I don't know. Okay, number 4. What was given in number 4? That let f be an entire function and what else is given, such that there is some natural number with the property that modulus of fz is greater or equals to modulus of z to the power n as mod z tends to infinity. Okay, show that f is a polynomial of degree n. So one thing to note is that clearly modulus of fz goes to infinity as mod z goes to infinity. That is very obvious, right? Because fz is greater, modulus of fz is greater or equals to mod z to the power n. So if this goes to infinity, then definitely modulus of fz will also go to infinity. And just in the last class, sir has done a theorem following the fundamental theorem of algebra that if this happens, what can I say? That fz is a polynomial. Just follow the last lecture notes. Do you agree with this line what I have written? Just follow lecture 12 what sir has taught. This is the theorem what sir has done, that if modulus of some function tends to infinity as z tends to infinity, then that function must be a polynomial, right?
Yes.
Yes, sir.
So the question was, show that f is a polynomial of degree at least 10. That means you have to prove that degree of f, I have proved that it is a polynomial, so I have to prove that the degree is at least 10. Okay, so I'll start with the contrary. So suppose degree is, suppose this is not true, suppose this does not hold, then suppose degree of f is not greater or equal to n, that means degree of f is less than n. And I'll show that this will lead to a contradiction. So then, or let f be of the form a0 plus a1z plus so on an minus 1 zn minus 1. So it will be a polynomial of this form when it is of degree this. So from this, just note that, okay? So as, okay, I'll simply use this. What is modulus of fz? Let's calculate the modulus of fz, which is modulus of this quantity. Use the triangle inequality to get something like this. This is lesser equals to modulus of a0 plus a1z plus modulus of a n minus 1 zn minus 1, right?
Yes, sir.
Now this is modulus of fz. So taking, so as mod z tends to infinity, we have, so when I'm assuming mod z tending to infinity, when I'm letting mod z tends to infinity, use this condition. Okay, so what condition do you have? That modulus of z to the power n is lesser equals to modulus of fz, right? And I'm just writing in the opposite manner, and this is nothing but lesser equals to modulus of a0 plus modulus of a1z right? I can actually write this way. This implies 1 is lesser equals to a0 by modulus of z to the power n plus this. Do you agree what I have written here?
Yes, sir.
So which goes to 0, because mod z tends to infinity, this goes to 0, which is a contradiction, because 1 is not lesser equal to 0, a contradiction. So therefore degree of f is at least n. So this was my approach. Anyone else has tried this question with a different approach? Can share their thoughts. Any approach that you had tried for this question? Okay, so then I'll assume that you have not tried this question. Okay, next 5, I had like it was the solution as given in the book by Joseph, that book, but I did not understand the solution, so I am trying in a different manner. If you have understood the solution, then it's fine, but I have tried that question, but I was not able to understand the solution, so I'm trying in a different manner. If I can do it, I'll definitely send you the solution. Has anyone tried number 5? No one. Okay, so the solution is indeed given in the book, but it is not clear, so that is the reason I will not be able to explain you the solution at this moment. So I am trying in a different manner. Let's go to 6. So let f belongs to HB02. What is the meaning of this?
All set of all holomorphic function belongs to on the this domain.
Right. That means f. So if f is in this, what does this means? F is a map from B02 to C, and f is actually analytic or holomorphic, right? So this simply means that,
Yes, sir.
right, this simply means that f is a function defined on this circle that centered at, not circle, this whole disk centered at origin and radius to C, and this is actually holomorphic. So this we know that f is a holomorphic function defined in this domain. Show that to show there exists some natural number such that f of 1 by n is not equals to 1 by n plus 1. So there will be at least one natural number for which this will happen. Okay, you have to prove that if it is a holomorphic function. So whenever you see this kind of statements, you definitely have to apply the uniqueness theorem or the identity theorem, which is again discussed in the class. So let me start with the solution. So if f is a constant function, then we are done. Do you agree why this is true? If f is a constant function, this line will be automatically proved. Do you agree with this line or no?
Yes, sir.
Right.
Yes, sir.
Right. Suppose f takes the value 2 every time, right? So f of 1 only we take, f of 1 by 1 is not equals to 1 by 2. So we are done. Okay. So this is indeed true. So if f is constant function, there is nothing to prove. So we'll assume that f is non-constant. Okay. So suppose f is non-constant. So I'll again prove this with a contradiction. So let for every natural number, what is the negation of this line? What is the negation of this line? That for every natural number, we have
f of 1 by n.
f of n equals to 1 by n plus 1.
right. So I'll show that if this happens, we will lead to this will lead to a contradiction, and hence we are done. Okay, so I'm assuming that for every natural number n, we have that f of 1 by n is same as 1 by n plus 1. So define g of z like this: fz minus excuse me, minus 1 by n plus 1 Okay, there is a problem. I cannot define the function in this manner for a fixed n. Okay. Just a minute. We have the approach to this question. I have made some mistake, I guess, for doing the sum. The solution that I have done is indeed wrong. I'm realizing it now. Okay. I cannot define the function like this because this n is not fixed. If I am fixing the particular n, so initially I have done it this way, which I am going to state now, but it is a wrong solution because this makes no sense. For that I have to fix a particular n. Okay, anyways. So now I'll define this function. I don't know. Let me try it a different way. Z by 1 plus z. I'll tell you why I'm considering this function. It is analytic. Okay, just give me 2 minutes. What is the problem in my proof? There is some problem in my proof.
Define
Yes.
G like fz minus z upon 1 plus z
Fz.
minus z upon 1 plus z.
Okay.
Then every natural number, this function has a root. Sorry, मतलब 1 upon n का रूट होगा और वो जो उसका लिमिट पॉइंट है वो डोमेन में है. This function is identically 0.
Right. This I had also done in the same way, but I don't know why did I take 1 by n plus 1, right? So define the function gz. No, instead of taking but one more problem is that this function is not is this analytic on 0 2? No, minus 1 में analytic नहीं है. Then you have to just consider that fact. Okay, just a minute. So let me define this way for the time being. Let's see what happens. So you might be thinking अचानक से ये function z by 1 plus z कैसे आ गया? So you have to find such a function. You have to find such a function जिसके लिए ये चीज true हो. G of 1 by n is also 1 by n plus 1. You have to construct such an analytic function जिसके लिए ये चीज true हो. So how can I do that? Just check करो. G of 1 by n क्या आएगा? This will be 1 by n by 1 plus 1 by n. What are we getting? 1 by n by 1 plus n by n. Yeah, you are getting that. So 1 by 1 plus n. What who was that who was speaking just now? That is also correct. तुम वैसे भी ले सकते थे fz minus this. That is also right. Okay. So if you want to take that way, then it is also fine. But ये जो मैंने बोला वो भी right होगा. So
Yes.
if it says right, gz is fz minus this quantity, right? So what is g of 1 by n? Then it is 0. I'll explain just a minute. So then g of z is 0, or g of 1 by n is 0 for all n in n. So basically you have to construct such a function g. You can construct in two manners. One way of construction is you have to construct this g, or another way to construct this analytic function is you have to construct such a g which is this. दोनों से आंसर आएगा. Okay. So now use the identity theorem. So what can I say? What can I say? This function gz vanishes on a set with a limit point in this. So I'll explain this line. So you see, you consider this set 1 by n such that n in n. So what is the limit point of this set? 0. 0 is one limit point of this set, only limit point of this set, and this lies in the domain. So by the identity theorem, this function will vanish on whole of its domain. This is what the identity theorem says. So by the identity theorem, what can I say? That g of z will be identically 0 in the whole domain. So understand the statement of the, okay, b01 लिख सकते हैं फिर I'll simply, okay, that's fine. b01, keep that in mind. g जो define है वो इस डोमेन में डिफाइन नहीं है. Okay, इस डोमेन में डिफाइन नहीं है. g is defined because you see this function is undefined at z equals to -1. Okay, so that -1 you cannot take here. Okay, am I clear up to here or not clear?
Yes.
Right. So gz is 0. That means if gz is 0, that means what I have, fz is nothing but z by 1 plus z, right? For all z inside B01.
Yes.
But I know that f is analytic in whole of 02, but you note here, but f is given to be analytic on B02, in particular at z equals to -1. This is the contradiction. Why?
Whole of order 1.
You see, अगर fz ये function है on B01, then it is somewhat undefined at 1. You see why? At -1, sorry. This is a contradiction, since if you see this limit z tends to -1 fz, which is nothing but limit z tends to -1 z by 1 plus z doesn't exist. So that cannot be analytic at 0. Okay, so our assumption was wrong. That what was our assumption? For all n this is true, so there will be at least one n for which this is not true. So thus there exists some n in n with this property that f of 1 by n is not equals to 1 by n plus 1. This is your okay. So use identity theorem. That's all. So that's all for today. Thank you. Acha.
सर
Yes.
सर अगर g को g इक्वल्स टू z अपॉन में 1 प्लस z लेते तो देन आफ्टर कैसे प्रोसीड करते, क्योंकि वो वाली जो थ्योरम है सर ने करवाई नहीं है अभी.
समझा नहीं मैंने, वापस बोला. अगर तुम g को बोल रहे हो z by 1 plus z लेते ना.
या सर.
हाँ देन क्योंकि g देन उस केस में तुमको ये लिखना पड़ता है. स्टेटमेंट तुम्हारा ऐसा होता है gz इक्वल्स टू fz ऑन b ऑन दिस सेट. एक ही बात है, n in n एंड दिस टू अग्री. अगर तुम gz को लेते z by 1 plus z, देन तुम्हारा gz और fz ये सेट पे अग्री करेगा, बिकॉज g of 1 by n भी होता है 1 by n plus 1 और f of 1 by n भी होता है 1 by n plus 1. सो एंड इसका एक लिमिट पॉइंट डोमेन में बिलोंग करेगा. इसका एक लिमिट पॉइंट है 0 और 0 बिलोंग्स टू b01. सो इसका मतलब दिस टू फंक्शन एग्जैक्टली सेम होगा, हर आइडेंटिकल होगा ऑन द होल ऑफ द डोमेन ऑन b01. एक ही बात होता है, दोनों में से एक ही आंसर आएगा, राइट?
ओके.
Even if you are taking in this way, that's fine. अच्छा, कल तुम लोग का एग्जाम कितना बजे से है?
मंडे को है सर.
मंडे.
कितना बजे से मंडे को?
सर मॉर्निंग में 10.
अच्छा, ओके, थैंक यू. मुझे टाइमिंग नहीं पता था. स्टॉप द रिकॉर्डिंग.